Hello everyone! Welcome to the first episode of the Devlog series about modding Barnyard the video game. If you are here for the first time and don't know about the decompilation of this game and its engine, I would recommend you watching my previous video first then. Let me explain what kind of things you can expect to see in my devlogs and in this episode in particular. For the past few years, I've been modding this game to achieve different things like exporting the models, replacing textures, adding some new things to the game environment, or restoring its beta features like throwing items, adding gnomes, mushrooms, restoring beta pool, and more. All of the mentioned things can be kind of seen in various videos on my channel. However, I think discussing some technical aspects is also worthy, so I decided to make devlogs about various things that I work on. And as you have probably already noticed from the video title and the thumbnail, I will talk about porting the game to a newer graphics API, DirectX 11. By the end of the video, we will have the original game renderer removed to have the game running in headless mode, just to initialize DirectX 11 API. As a bonus, we will also rework the way text is rendered by the engine, because due to the currently used technique, it's very blurry at high screen resolutions. First of all, let me explain what a graphics API is, because that is really important to the subject of this video. The main purpose of the graphics API is to let application do various drawings with the use of your GPU. To be more precise, graphics APIs provide programmers a way to communicate with PC video driver, whether it's an NVIDIA driver, an Intel driver, or an AMD driver. You have probably heard of some graphics APIs such as DirectX, OpenGL, or Vulkan. Actually, those are the main three. Support of the graphics APIs is the responsibility of driver developers, but I think you can already guess what usually happens to the old graphics APIs, right? As the time passes, some things can break, leading to various unexpected things to happen on some hardware due to poor support of the old APIs.
Very late stream. Now please just get the rock animation skip. What? What? Excuse me?
Changing the API used in game is actually possible without modifying the game code. One of the most popular libraries that lets you do it is called the XVK. The main purpose is to translate DirectX calls into Vulkan calls and make it act the same way. It is widely used to fix various issues in old games on Windows, and moreover it is the main way to launch Windows games on Linux with the use of Wine or Proton by Valve. So almost every time you play a game on Steam Deck, you play with the XVK, unless the game has a native support for Linux. Though some games can have native ports and still use the XVK. Anyways, the XVK is pretty straightforward and easy to install and to use, so there is no challenge, like at all. And that's why it's not the way I chose. In addition, the XVK causes some other issues in the game and doesn't give you a way to heavily modify the renderer, adding some new features, which is what I want to. So for today, the plan is to completely remove DirectX 8.1 from the engine, to integrate SDL2 library which will manage the graphics window, and to develop a new font renderer that will utilize signal distant fill to render text in high quality. So, what do we need to get rid of the old graphics API? In the Toshi game engine, you have a few abstractions over it. The renderer called T-Render Interface and the shaders. There are few main shaders: a world shader, a skin shader, a grass shader, and a sys shader. You might wonder what does T or A at the beginning of their names stands for. T stands for Toshi, meaning that the implementation of the class is in the engine codebase. And A stands for application, meaning the implementation is in specific application codebase. Talking about the renderer class, there's not just T-Render interface, but also T-Render D3D interface, which implements the actual DirectX 8.1 library, so we need to get rid of it first. Then we will need to replace every shader with a stub that won't do anything to make sure the game doesn't crash, because it can use the old API which will become uninitialized. But how do we even do it? Well, we need to find the exact place where the engine or the game initializes renderer. Thanks to the fact that I'm decompiling the game, it's no problem for me. The game has a renderer class, which implements create-to-render method, and that's the one that needs to be hooked and replaced. By hooked, I mean a specific technique that allows to replace a function within a compiled binary file without recompiling it, so it is possible to do even without the original source code. I'm going to skip the hooking process as it is mostly handled by the mod loader and it's boring, as well as DirectX 11 initialization, which will be the same as for any other application. The original D3D interface class is also responsible for creating a window to draw, so the custom one will also need to do it. But instead of using the original TMS window class, we will use the SDL2 library that can handle it for us. The reason for this is that it's much more stable and it doesn't have issues the original one causes on nowadays Windows. Having that function and the class replaced lets us to create our own custom window and initialize DirectX 11. But unfortunately that's not enough because the other parts of the game work as before and they are actively trying to use the old API. I found at least 40 methods that I needed to replace with stubs, so I did it. And now when I launch the game I can see this empty window. It will be funny to hear without any context, but it makes me happy to see an empty window when I'm launching a 2006 game. The good thing is that it doesn't crash and I can hear the game audio, so it makes me confident I did everything right. Well, except the fact that I'm actually doing this, but anyways. I have remade a few methods just to make sure everything works fine, and one of those methods is actually critically important as it defines the viewport size in which the graphics API will perform drawings. It also sets a clear color, which is used to fill the screen with before drawing a new frame. If you don't know how a game frame is rendered, here's a little slideshow in which a game frame is being rendered step by step. This is of course not visible to you while playing games due to double buffering, but that's what happens all of the time for every frame you see. It turned out that the game uses this type of green color to clear frame, and you can notice it in the original game too if you enable fly hack and get out of the night barn. At this moment we have like 70% of what I wanted to showcase in this video. The other 30% is the new font renderer. Original game utilizes ArgUI2 renderer to render UI and the text is not an exception. So I need to rework it in order to make the interface appear in my port. Luckily, its shader is not really complex, as it is simply drawing 2D triangles with specified textures on the screen, and there is not much to be done. I have reverse engineered the original shader and come up with this shader code for DirectX 11. A bit of magic made in the background and we have it running in the game. As you can see, the original game interface appeared in our DirectX 11 window and that's nice. But let's see, I have mentioned that I wanted to implement my own font renderer. The original renderer uses a pre-generated font atlas and you can see it right now on the screen. You can notice that the number of characters is pretty limited and doesn't have, for example, Cyrillic or Chinese glyphs. Unfortunately, that's what makes the localization process much harder. From what I know, there are only 3 official localizations made with different font atlases. The Russian one for PC, the Korean one for PS2, and the Japanese one for VE. My goal is to make the new font renderer generate font atlas at runtime, so any character from font can be rendered and there will be no such limitation anymore. The first prototype I have implemented was using Microsoft's DirectWrite library. That was the easiest one to integrate fast. And it was really fast thing to integrate, but then I realized it has a lot of different issues, including very poor performance and many other limitations, like not being able to debug the application in RenderDoc anymore, since DirectWrite is using some undocumented features of Direct2D. That's why I decided to get rid of DirectWrite and use an open source alternative called FreeType. It is much more widely used in various software and has much more options to change, so it's a great library for me. In addition, it has an option to generate signal distant field glyphs. It means that instead of rendering the glyph of the font atlas like usual, it will render the shortest distance from any point in space to the surface of a shape. with a sign indicating whether the point is inside or outside the shape. It will ensure that the quality stays cool even with some scaling applied to the text, without remaking the atlas texture. Integrating FreeType took me some more time, but at the end it paid off a lot. The performance got so much better, and thanks to SDF the scaly text became sharper. And as you can see, I can enter the main game without any problem, so now I just need to make the world and the other models be rendered too. And that's what I'm going to do in the next episodes of this Devlog series. I have left a link to the repository of this project in the description, so check it out if you're interested. See ya!